Our next task is to sort of comb through what we mean by this phrase, sufficiently large. And we won't drag this out too long, but it is enough to say that for the work that we will be doing, vast experience, by which I mean years and years of professional work, vast experience has shown that there are two ways to meet the sufficiently large requirement. Two ways to meet the sufficiently large requirement. If you meet either of these two conditions, then you have met the sufficiently large requirement. Either of these two. You do not need to meet both of them. If you do meet both of them, so much the better. But either one of these is enough to meet the sufficiently large standard. In no particular order, one way is this. If the original population, I'll say, if the original population or data, if the original data are normally distributed, if the original data set that you take the sample from, if the original population from which you draw the sample is known to be normally distributed, then any n is sufficiently large. If the original data set is known to be normally distributed, any n is sufficiently large. N equal to 3 is large enough. N equal to 50. N equal to 700. N equal to 4. N equal to 1. N equal to 2. Any n is sufficiently large if the original data are known to be normally distributed. For our purposes, that will need to be explicitly stated in the problem. So, if the problem says, a sample of size 5 is taken from a population which is known to be normally distributed. Well, you've been given the population is known to be normally distributed, and so sample of size 5 is sufficiently large. So if that phrase is stated somewhere in the problem, then any sample size is large enough. If this phrase is present, then you have met the sufficiently large standard and you're good to go. Now, suppose this phrase is not in the problem. All right, you do not know that the original population is normally distributed. In that scenario, the other way to meet the requirement is this. Vast experience has shown 30 is the cutoff. For our purposes, greater than or equal to 30 will be sufficiently large. So if it's greater than or equal to 30, it doesn't matter what else is happening. You have met this requirement and you're good to go. If the population is known to be normally distributed, then you've met this condition, you're good to go. If you have met both of them, if it says the population is normal and the sample size is, let's say, 70, then coincidentally you've met both conditions and you're good to go. If, however, it simply says a sample of size 4 is taken from a population and blah, blah, blah. You have not met this condition, you have not met this condition, so you may not use the results we're going to talk about here. For our purposes, for the work that we're going to do, either one or the other or both of these will always be met. At the freshman level, we will meet one or the other of these. So one way to make it easy is if I just say, suppose the sample is size, we take a sample of size 80, well then you're good to go. Suppose it says, a normally distributed population has blah, blah, blah. It doesn't matter what else follows. If it says normally distributed population, then the sample can be size 12 and is fine, or 3, or 90, or anything, because if it is normally distributed, any n is sufficiently large. So these are the two conditions for our purposes. At least one, maybe both, but at least one of these conditions must be met in order to meet the condition for sufficiently large. For our purposes, they will be, but one of these conditions must be met in order to use the techniques we're going to talk about next.